Yeah, so why are you asking me to do them all?
So we can do every other one. Is that a joke?
That is a joke.
It says it right there. It says do at least every other, starting with A. T. We do.
Now, these are all easy. The ones that get complicated is when we go into polyatomic ions.
Wait, can you like keep GG was toffee.
Okay, so the ones that people have asked in other classes are like phosphorus pentafluoride. So we have these, they don't actually have charges, right? Only ionic things have charges. Like sodium and chlorine, they have charges because it's ionic, right? But, so let me tell you again. If we have something that is ionic, they have charges. The sodium gives the electron to the chlorine and you make that salt, right? So the sodium is definitely a plus and the chlorine is definitely a minus, right? But if you have something like H2O, in here what's happening, the electrons are being shared. So each atom has a charge. No, they don't have a charge. The electrons are being shared. But in order for us to be able to do redox reactions, we're gonna assign charges to those. And we go by the rules that we talked last time. Fluorine will always be no exceptions. So if you see a fluorine, you go by that first. Alkali metals, +1, no exceptions. So if you see an alkali metal, you do that first. The next one is hydrogen, is always what? +1. But it will have one exception that you don't really need to know because alkali metals have no exception. So obviously if it's a metal hydride, NaH, alkali metal hydride, it will be negative. It will be negative. It'll be -1 and this will be +1 because this one has no exceptions. Alkali metals have no exceptions.
What are the exceptions for hydrogen?
Alkali metals. Oxygen is always -2, right? Unless it is with an alkali metal or a hydrogen in a 1-to-1 ratio. So if it's in a peroxide, and the one that we will talk about is H2O2, that is hydrogen peroxide. What is the charge of oxygen then? -1, right? It's minus. The other exception is sometimes you can have something like OF2. What is the charge of oxygen then?
+2.
Yes, right? How weird. But fluorine has no exceptions. Alkali metals have no exceptions. Alkali earth metals for the most part will be +2. So if you have other things, you tend to give that to them. If they happen to be with fluorine or something and they make them do something else, that's a different story. The boron group 3, carbon 4, nitrogen, ta-da-da, unless one of these ones makes it different, calls it out. Like, let's say we have, I don't know, KClO2. Let's see what happens here. The K will be what? +1. That's an alkali metal, right? The ClO will be a minus, right? Because we know HClO4 is a minus and that has to be a minus anyway. So ClO is a minus. The overall charge is minus. The O is what? -2. The Cl is +1. Right? So Cl will be +1. What? Since when, right? Since here, because these are not real charges. This is something that we are assigning to a polyatomic ion, which are all considered to be covalently bonded. All polyatomic ions are an ion because they're not a salt, they are just a unit that is covalently bonded. So we are gonna assign charges to them. In order to be able to do a redox reduction, you need to have those charges to see what we think is going on. Grace.
So, not just like O2.
I want to know the charge of the atom. If you have two, that means that you have, let's say, which one that has subscripts? Like HClO2. So in this case, the K is still a plus, the ClO2 is a minus still. So the O is what? What is the charge of the oxygen? -2, but you have 2, so it will be a total of -4. But the oxygen charge is -2. The Cl will be what? +4. No, +3. Because +3 - 4 is equal to +1, right?
But in class yesterday you said like not like just to do the charge of the atom.
Yeah, the atom, but the Cl is by itself. So the charge of oxygen in here will be -2, but on this one will be +4. I'm not saying that the charge is -4 for oxygen, right? If you were including the subscript, then I'll say oxygen is -4, but oxygen is not -4. You have two oxygens, each one of those with a -2 charge, right? It's two oxygens, each with a -2 charge. So we don't do the overall charge, we do the charge of the atom. KClO3 is gonna change. This is gonna be a plus, this is gonna be a -2. We know that, right? But the ClO3 is still a minus. That's -2, so it's -6. What is the charge of Cl in here? +5. Yeah, if you know how to do those, then you've got this.
Wait.
And sometimes they have charges that are like, they don't make much sense, but that's how we keep track of the charges on redox reactions. We need to do this.
If the
Yes.
total charge of the ClO3's total charge is -2, wouldn't chlorine be +4 because oxygen is -2?
ClO3, so that's -2, so that's -6, right? The whole thing is a minus.
Oh,
So -6 plus what?
oh,
5. 5 minus 6 is a minus charge overall, right? Are we okay with this?
Wait,
So-
Miss Thompson, why is it not -2 on that? Like, I thought the whole thing was -2.
No, ClO3 is -1.
That's like
Chlorine, oxygen, minus,
you were the -2, you were just talking about oxygen.
-2 is the oxygen, yeah.
What's the charge of the K?
The K is always what? +1. Right? So the K here, 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 here is all +1.
All of the Ks?
Yeah, it's an alkali metal. And all the ClO, ClO2, and ClO3 are -1 because they're all with that K, right? But you also know, right? So if this side is a positive, in order for you to have a neutral compound, what does the ClO have to be? A negative, right? Then the neutral. This is neutral as well. So the K is positive, what does ClO2 have to be? Just a negative, so that is 0 as well. What about here? This is a positive, that's the ClO3. So they all have the same charge for the polyatomic ion, although the oxygens are changing, right? But the hydrogens are not, or the potassiums are not. So that's all gonna be negatives so that you get a neutral charge, right? Does that make sense? Now let's go to part B. These are the interesting ones. So here, if I ask you to balance or to write the half reactions, you need to do the oxidation and then you need to do the reduction. Which one do you want me to do?
It doesn't ask for
Wait,
that.
this one just says
This is
which
just
one?
asking what's being oxidized and what's being reduced. On the back side.
Can you do number 4 though?
Well, no, can you just like tell us which one is oxidized and which one's reduced?
Can you tell me Which one is oxidized? 2 plus 3 to plus 2. What happened to that one? It's going smaller, right? Smaller means reduced. More negative, more like oxygen, more negative is reduced. It gained electrons. It what? It lost electrons. What? Wait a minute, we're confusing each other. It going from plus 3 to plus 2. That's being reduced is gaining electrons. So gaining electrons means going a smaller charge. The charge is getting reduced. It's going from a plus 3 to a plus 2. That's getting reduced. The charge is getting reduced. Then if it goes negative, it gets even more reduced, right? So that's reduced. The plus 2 to plus 3 is increasing, right? So that is oxidized. 0 to minus. Reduce is going smaller, right? Minus to 0. Oxidized. 0 to plus 4. Plus 5 to plus 4. Minus 2 to 0.
Wait, this is just not.
How does number 3 work? Because
0 to plus 4.
right.
Oxidized. Plus 5 to plus 4.
But that's like not even.
Oh, you're going to have to balance the charges. Yeah, we're not balancing because you're like, oh, they didn't have to balance. But I would love to balance the charges.
No, we don't have to.
Because balancing charges is an important part of life.
I can do that.
Yes. So, minus 2 to 0. Yes, it's oxidized, which means the copper got reduced, right? Potassium that never changes. We don't care about potassium. So 0 to minus 1, reduced. 0, no, that's not 0. Minus 1 to 0, oxidized. Minus 4 to plus 4.
Is that carbon?
Yeah. Oxidized, and the oxygen got reduced, which happens in every combustion reaction.
What happened to the hydrogen?
Nothing happened to it. Plus 1 and plus 1. Hydrogen. Only one element will be oxidized, and only one will be reduced for us.
The carbon got oxidized? Or the carbon
The carbon went from minus to plus. The charge increased. What is that? Nombre? Minus is becoming more positive. Right?
So it got oxidized?
Yeah, more positive. What gets positive? The metals get rid of electrons and they become more positive, right? Right? Double displacement, is that a redox reaction? So who cares? You don't have to do that. I mean, you can, you want to. But, that's what you need to balance. I do want you to know how to balance. Is this balanced in atoms? Is it balanced in charges? Did we balance it before?
I came here during office hours.
Oh, so let's balance it. Chromium goes from, iron goes from 2 to 3, so my oxidation. Fe 2 plus goes to Fe 3 plus. That got oxidized. Does they have reaction?
Do you have to write the plus E minus?
Yes. So I'm gonna skip it for now. I'm gonna just write which one got oxidized, which one got reduced. The Cr3 plus goes into Cr2 plus, right? That got reduced. How many electrons were lost? You lose to the right.
1.
How many electrons were gained? You gain on the left. 1. You lost 1, you gain 1 electron transfer, we're fine. There is no need to balance that equation, right? So that equation was actually balanced. And if you see you have plus 3 and plus 2, that's 5, and plus 3 and plus 2, that's 5, so that's fine. Now, this other one, the T went from 0 to plus 4, what happened to it?
Oxidized.
And then the nitrogen went from +5 to 4 plus. That got reduced. How many electrons? How many electrons? So what do I do here to make sure that I gain and lose the same amount? I have to multiply this one? No. No. What?
Yes.
Yeah, you multiply.
This one times 4, right? So when I multiply it, I get 4 nitrogen, 5 plus. We have 4 electrons, so they cancel, which is what I wanted. And I get 4 nitrogen, 4 plus. So in reality, you should have a 4 here and a 4 here in the balanced equation. I'm gonna miss him next year. Some students, some senior students. Now, you always miss the seniors. You know, the beauty of me is that I teach sophomores, right? So I get to see them their junior year, some of them for AP, and then you get to see them and then they leave, which is okay. It'll be awful to teach seniors. You teach them and they're gone. Thank you. So this goes from, do you want another one?
Yeah.
So this goes from 0, that's a plus and that's a minus.
It's balanced.
It's balanced. And this one,
Oh, also it's decomposition.
this is not a redox.
No, because it's decomposition.
All you're doing is breaking something apart, right? It had the charges and then you dissolved it and now you have the charges. So that's definitely not a redox.
So decomposition is not redox.
I would say that you're dissolving it.
But not all decompositions are not redox.
I would not call that
I
decomposition.
looked it up and it was like
They called it
Some are.
decomposition.
Yeah.
it was like some
Because in my opinion, what you did in here is you had a solid salt, right? And you didn't break it apart into its elements. That's what I will call decomposition. No, you're just dissolving. This is not a reaction. This is a physical change, some people call it. You're just dissolving it. Excuse me? There is no exchange of, no, electrons were not exchanged at all.
So what about the next one?
In AP chemistry, they consider that a chemical change, but it's still not a chemical reaction. In this one, that is decomposition. That is decomposition, and that is redox. So don't call that not redox because it's decomposition, because that's not decomposition, and that is not redox. This, you added heat and you broke it up. You reduced the copper, and you ended up with solid copper and oxygen gas. So in this one, this is 0 and this is 0. So for sure you're going to have a redox reaction.
Can you do it?
The oxygen is what? The oxygen is -2, which means that the copper is what? So it's a total of +2, right? So copper goes from +1. Copper goes from +1 to 0. And you have to balance the atoms first before you balance the charges. So I'm glad we're having number 4. You have 2 coppers over here and 1 copper over here, right? So you're gonna have to put a 2 here. You have to balance the atoms first, or otherwise you're gonna be all messed up with the charges. Right?
So there's a loss of 1 electron. Yes, there's a gain of
You're
1.
gaining how many?
1.
You had 2 coppers with a plus charge, and then you had 2 coppers with a 0 charge. How many electrons were overall? 2. Plus 2 electrons. That's a reduction part. And the oxidation part is the oxygen goes from -2 to O2 minus, no, to go to 0. How do I do this, Kate? You have 2 oxygens here. What should you do there? 2. So you balance the atoms before anything. Now you have 2 O2 minuses, and then you have an O2, 2 oxygens with a 0. How many electrons did you lose? 4. Yeah?
Do you have to change the copper too? Like, because in your actual reaction, because you balanced it, you put a 2 for the CO2.
Well, so just wait. You had here, you lost 4 electrons, right? So you lost 4 and you gained 2
Wait, how'd you lose?
because you had 2 O minus 2s and 2 O, right? So it's 4. You cannot gain 2 and lose 4. So what do I do?
Times the copper by 2.
Times this by 2. So you end up with 4, 2, 4, right? And now my 4 electrons will cancel, and I'm okay. Now my overall reaction should have 2 coppers, and then you're gonna make 2 O's, right? It's right there, these 2 join, and then we're going to get 4 coppers, and the O2. And now it should be balanced in atoms and in charges.
Wait.
So it is a way of balancing a redox reaction. If I don't have any charges, I will not balance using this method. I will balance first, right? Because it's easy to balance that equation without the charges, right? So if I don't have any charges like this, I wouldn't even bother with balancing with redox. I'll balance first and then I'll do my redox reaction. So I don't have to think about how many electrons, I just have it, right? Does that make sense? It's much easier to balance this just by looking at it than to do a redox. You leave the redox for this type of reactions. When we don't know what else, because these are net ionic equations, right? We don't know what these were combined with. So you do redox for these. You do not do redox for balancing these ones. You just balance it first and then do the redox part. Right? So that's what that is. In here, all of these ones, you should balance and then do the reduction, oxidation, number of electrons. But if you balance it first, it's much easier. You can balance this in 2 seconds, right? That's easy to balance. And then you just break it up into reduction and oxidation.
For the first one, would it be a 2 in front of that one?
Right? And after you do that, then you don't have to worry about how many electrons and all that nonsense, right? You just do it. The half reaction is, this is the oxidation is this one, so this is 0 to plus, and this is 0 to minus 2, right? So hydrogen is being oxidized, that's my half reaction, is 2H2. 2H2, right? And then for the oxygen is O2, 2O.
So you don't have to put the charges for O.
And then you have to say reducing, you gain 4 electrons. This one's 4 electrons. Since I balanced it early, I know they're right. It was already balanced. I don't have, so 4 electrons were transferred. Somebody lost 4 and somebody gained 4. The oxygen gained 4 electrons, total of 4 electrons, and the hydrogen lost a total of 4 electrons. Got got reduced.
So wouldn't that be on the
Wait a minute, what?
I think wouldn't oxygen, it went from 0 to minus 2, so wouldn't it be?
Reduced. The charge is being reduced. It's going from something big to something small, right?
Do you always put a plus sign when you say how many electrons, or do you put a minus?
You add them to the left when you are gaining them, and you add them to the right when you are losing them, because you lose on the product side and you gain on the reactant side.
You
That's
never put a subtraction.
no, and I will always think about Aviva Siretti because it made him mad. He's like, why can't I just put minus instead of having to add it to the other side, right? I don't know why, but that's the way it goes. It's the standard. You do not put minuses. I've never seen anybody put a minus. But yeah, this is math, and theoretically it is the same thing, but we never subtract atoms. I've never seen, I don't know. I can think of one now, maybe we do at some point, but no, we always put gaining on the left, losing on the right. But yeah, you could take these 4 electrons and subtract them on that side, or this and subtract them on this side. This is math. So you could do that, but you shouldn't. Just use the same that everybody else does. Any other questions in there?
Can you do number 3?
Number 3. You have carbon and sulfur. Sulfur. So carbon. Carbon, I forget, is that, I think this was reduction. So carbon goes from 0 to +4, that gets oxidized. Carbon goes from 0 to carbon 4 plus. And it lost 4 electrons. Oh, I didn't balance it. You want me to balance it first? Because this one doesn't need, it doesn't really matter. But I know I have 8, so I must have 4 over here, so I must have 4 over here. This will make it easier. So now I now have 4 carbons that are 0, that are going into 4 carbons that are plus 4. So there were 4 electrons. No? How many electrons? 16 electrons. And then the sulfur 8 goes into S2 minus 2.
Would you do 4s2?
Yep. So 4 times 2 is 8 times 2 is 16, right? So that one is gaining 16 electrons. So it's 16 and 16.
So it should be, the amount of electrons should be equal on each.
If I give you something, you get one thing, right? If I give you 2 things, you get 2 things. I can never give 1 and the person get 5. That's just not gonna happen. What on earth are you doing, Zach?
Just making sure I have all my sounds organized.
But you're not paying attention. You're still paying attention?
I zoned out for that last one. I'm not
Mhm.
gonna lie.
Yes.
Okay, so whenever it's being reduced, do I have to put like the subscript, like S2?
Yeah.
Or I just put
4s2. Now, oh shoot.
Where is
Yeah.
Zach, where?
Now,